Thank you everyone for coming. Today's webinar is given by Melanie Pierce of Idaho National Laboratory, who is a cybersecurity analyst there. She joined in 2022 and is currently doing her master's in computer science. And with that, I'm just going to give over to her. Thank you very much for agreeing to give this talk.
Yeah, absolutely. Thank you so much for having me. I'm excited to talk about Parsnip. Parsnip is a tool we built at Idaho National Lab. It is proof that Idaho can do more than potatoes, but isn't brave enough to move past root vegetables yet either. Parsnip is a tool designed to kind of lower the barrier of entry for parser development. And we'll talk a little bit more about that. I'll tell you kind of a story of the main use case we see for Parsnip as we get there. But before we get started, just kind of an executive summary. If you tune out the rest of it, please don't. But if you do, here's kind of what you need to know about Parsnip as a whole. Parsnip is designed to ease development for both our spicy developers and for people that aren't really developers. It helps keep a consistent structure among our team so that a team member that starts with a Parsnip framework and then develops the rest in spicy has the same format as someone that chooses to develop all the way in Parsnip. It's designed to lower the barrier of entry for parsers development. We'll talk more about this, but a lot of people that want to develop parsers or want my team to develop parsers don't have the programming desire and don't really want to go learn a new programming language. It's designed to allow for in-house development. One of the big issues we face in my team as a parsers team is getting test data. A lot of people don't want to share their proprietary test data. It makes sense, but it does make it hard for us to develop a protocol parser for them because we can't really test it. These people at particularly the small to medium-sized utilities we target with my division at INL don't have the resources, the time, or the people to go out and learn spicy. The hope of Parsnip is to enable them to build their own parser without spending the time or resources to go out and have a developer learn. It's designed to increase the speed of parsers development. There's some duplication of effort, particularly in how my team chooses to use spicy and leverage spicy to make it a little more intuitive for our analysts. And because of our particular use case, the level of verbosity our customers are asking for, we end up duplicating a lot of data. Most of this idea actually came out of some of the struggles I had with BinPAC previously. But there's similar struggles in spicy that we could avoid if we didn't have the use cases we had. And then Parsnip is free and open source, and it's always been intended to be free and open source from the beginning. I know that Zeek uses the term analyzer to refer to what we're doing, where you read packets, analyze them, and output data. My team has been using the term parsers long enough that I'm going to forget. I'm going to use the term parsers throughout this presentation, just to clarify some of the vocabulary. So the easiest way to kind of explain one of our big use cases for Parsnip, especially to, since most of you, or a lot of you are probably already familiar with spicy, is to talk about some of the stories some of my coworkers have experienced. Now this is kind of a conglomeration of several different stories, but a good summary. So we have, picture a team. We've got 3 analysts on this team. For the sake of discussion, we'll call them Jim, Justin, and Abigail. And these 3 analysts are called to Gander Water Treatment Facility in rural Mississippi. There is very, very few people around, and part of the incident that they're investigating is that Gander Water Treatment Facility's air conditioning has gone down. So they're in rural Mississippi in July in 100-degree weather, 90% humidity. They're probably already bitter. And they plug in their network sensors and they start looking at this traffic. And they're seeing traffic they understand and a bunch of traffic they don't know what it is. They can't figure out what protocol it is. There's no details. Zeek's best guess isn't working. And ultimately, they end up asking the operator of the facility. Well, the operator of the facility goes, yeah, that protocol is called Screech, and it is a custom protocol built by Dave over here. And Dave is the documentation for this protocol. There is no other documentation. Dave knows how it works. Hopefully Dave never retires or wins the lottery because we don't know how it works. Essentially, they go, okay, well, it might be kind of hard to parse. So they try to figure it out without Screech, without parsing Screech. And they go through, they're looking at their data, and pretty soon they hit a brick wall and just realized that they need to parse Screech. They could maybe go develop a spicy parser, but as Justin is fond of saying, if I'm developing, you should run in the other direction because that means something's gone real wrong. They're not developers, they don't want to be. They're technical, they're smart, but they don't want to develop. And that's where Parsnip can really come into play. They can sit down, work with Dave, the documentation of Screech, and build a parser that is good enough and quick enough to get them through the next 2 weeks of their engagement. Get them just the data they need. Maybe it's not the most robust parser, but it's a framework and a system that they can then plug into their tool, use it, and better look at all this data that they're seeing. That's where Parsnip really comes in. It's designed particularly for the people that aren't programmers and don't want to be programmers to be able to develop a spicy protocol parser. And that's important to us because, like I said, we support a bunch of incident response teams. We've had incident response teams ask for parsers and say, you know, how fast can you turn around a robust spicy parser without documentation? We had a customer ask us that and we said, kind of depends, but basically without documentation, the fastest we could turn around is 6 weeks. And the goal of Parsnip is to enable someone to say, here are the fields I really need out of this parser. Here's exactly what I need to see. And then the rest you can just kind of dump to the side and get you a good enough to last these 2 weeks or however long your engagement is. It also gives us a framework if one of our analysts was to go out and build that 80% parser to then go forward, and my team that is actually familiar with Spicy has a starting place to work from. So we're going to talk a little bit about the architecture of Parsnip. As I said, Parsnip isn't exactly designed for developers, but it's kind of based on the assumption that you have a little familiarity with how object-oriented design works. The way we say it is as of right now, and the hope is to make it even more intuitive, but as of right now, the goal is for anyone that's taken a CS 101 or very introductory object-oriented programming class to understand the basic principles of Parsnip. Now, Parsnip is built, and there are kind of 4 main features I want to talk about. There's objects, bit fields, enums, and switches. We'll get to switches on the next slide because they're a little different. But fields are kind of the basic building block of Parsnip. And you'll see when I pull up a demo in a few minutes, you'll see that fields, regardless of where they are, whether they're in enums or bit fields or objects, are all very similar. They all have a name, they all have a type, they all have optional references that we can add as comments or notes you can add as well. Enums are made of fields, and enums just function like any other standard enum, just like a spicy enum. And we use them as fields. We use fields to kind of define what character. Enum fields in particular also have the option for adding a human readable log value. So instead of merely stating its name, or if you wanted to give it an undescriptive name like enum1 is A, you could add the human readable value that says it's a reset flag. Enums are kind of the lowest level in that you can't, in Parsnip, you can't build on an enum. You can't have anything that an enum can't point to anything else. But then we move on to bit fields. Bit fields also function like bit fields in Spicy. Bit fields can point to enums. They can't directly point to objects, but they're designed to allow the user to split bytes into bits, just as a bit field in Spicy, and it's basically translated in the back end the exact same way. And then finally, we have objects. Objects are kind of the main central building block of Parsnip. An object is made up of fields, and possibly some of those fields are bit fields or enums. You can build an enum or a bit field on top, or you can have an object point to a bit field or an enum or a bit field with an enum inside. So this kind of building block structure is designed to illustrate what can and can't stack on top of each other in Parsnip. And then at the bottom, you'll see the entry point object. This is where we tell Spicy to start parsing. This is what we point to when we set up the Zeek Spicy integration and we set up the plugin, we'll point to the entry point object. So that's kind of the basic principles of bit fields, enums, objects. Entry point objects function just like objects, except they're typically also made up of objects, enums, and bit fields. So then choices. Choices are kind of an extension of enumerations. We also call them switches. The reason we left it at choices is, again, as we said, we are mainly targeting people who hate programming and or don't want to learn how to program. So we use the term choices to be just a little more friendly to them. The word switch can kind of be like, oh, dang it, I'm programming. And this is better for choices is kind of more of a more friendly term for them. They don't have to be like, but I don't want to program. Choices are an extension of enums. A choice is built and switches on each of the enum values in a field. And these enum fields, each of these enum values, can point to either an object or another field. This just comes out as a switch statement in Spicy, but in Parsnip itself, is structured as each choice field has options. Each option is represented by an enum, and then that enum option has an action. That action is either the field or the object it points to. That's kind of a basic summary of the syntax and kind of the structures of Parsnip. Any questions on that so far? Perfect, I'm seeing none. And I should have said earlier, if you have any questions as I'm talking, feel free to put them in the chat or in the Q&A, and I'm happy to answer them. So Parsnip's designed in 3 parts. The first part is the GUI interface. The GUI interface is supposed to be the friendly front end. It's going to be the easiest and most intuitive to use and the easiest for us to train, for example, an analyst that wants to learn how to use Parsnip on. The front end exposes the core functionality to users in a visual manner. Right now, this is kind of a beta introduction of the front end. Eventually, we're hoping to expand the front end to allow users to upload packets or captures and do kind of a point and click, highlight what bytes and say what it should be interpreted as. As of right now, it's more of this text-based structure, and we will work towards improving this. It contains import and export files specifically designed to allow users to save their progress as they're working locally. Right now, this is all self-hosted, and a big reason for that is just so we don't accidentally risk people uploading proprietary data somewhere public or somewhere they don't want it to be. The front end also has a review feature that manages and checks on if there's anything worth noting. For example, if you're referencing something that isn't defined, the review field will flag that and say that needs to be defined. The second part The second part is the intermediate language. Now, Spicy itself already is an intermediate language, but as I said, it's programming, and it's programming. This is JSON, which is a structure that our analysts are pretty familiar with. They use JSON when they're looking at data, when they're examining different captures, different logs. So they're a little more comfortable and a little more familiar with the idea of using JSON. These JSON object structures, this is what's actually fed into the backend of Parsnip and generates the Spicy output. If you're using the front end, we have conversion script that'll take your front end and move it into the intermediate language. It's particularly designed for more advanced users, and it'll provide additional options that we don't want to show to the GUI user just to avoid confusion or issues. Kind of if we're at a crawl, walk, run, where run being I'm a full Spicy developer, I can go develop Spicy, and the crawl being I'm just using the GUI. This is kind of a crawl walk stage. And the intermediate language is also specifically designed to be easy to work with programmatically. So originally the idea for Parsnip was to do PDF processing in Python, extract the information in the tables needed from a protocol spec directly, and then output it to JSON so that we could feed into Parsnip without pretty much any manual work other than supplying the PDF spec. We quickly discovered we're not quite there yet. We don't have the machine learning capabilities or the ability to read a PDF quite that well. But that's the ultimate goal as well, is that someone or us that is comfortable working with PDFs and data processing can take that PDF and plug it into the JSON format. And then finally, there's the backend. The backend's super not exciting, but it is the part that actually converts the intermediate language files into Spicy code. It outputs all the files necessary to create a ZKG package and make it installable. So the only thing the user would have to do at the end is to initialize the repository as a Git repository and ensure that it's a clean repository. Performance processing, it's actually pretty fast now. We have our biggest protocol. It used to take, I want to say 30 minutes to compile, and we switched out one of our libraries from a Python-based library to a C-based library, and we reduced that time. Now it compiles in, I think, about a minute. And it outputs analyzer scripts. One basic test, it'll output the availability test. Eventually, we would love to incorporate more tests. Similar issue as we had earlier with not hosting the front end anywhere. We don't want people putting in proprietary data and just naturally assuming they're safe. As well as your ZKG meta, it'll put out some comments as well. The future, eventually in the future, we'd also want it to put out a fairly solid README. Typically the ICS NPP repositories, which is what my team outputs, contain tables of all the fields and their descriptions. And we would love for the README the output README to contain this. It's also important to note that right now, Parsnip does output in a very verbose format. As I mentioned earlier, that's what our customers request. Particularly our hunt and incident response team really wants to see as much data as humanly possible, rather than us kind of summarizing it on the front end, on the Zeek end. So it is outputting very verbose, but it will include in the output policy log hooks so that you can turn on and off anything besides basically the header, if you would like. So now we're going to go into a demo. I'm not crazy enough to try to demo anything live. That's a recipe for something breaking, but we will kind of go into a demo of Parsnip that was pre-recorded. I'll stop it and I'll talk through some of this as we go through. So the front end is Dockerized. It can be started when you download from GitHub, you just go into the front end directory. It has a script to start your Docker container, and then you can start it using the main central app py that's built in. And it'll open up on port, I want to say port 5000. Again, this is designed to be run locally right now and used internally. Once you're in the browser, we can kind of take a look at the front end. Now, the front end has several components. The file component, this manages your snapshots and your saved files. The instructions component points you at the central documentation. The parser configuration is kind of your main first place to start. This is what defines what protocol you're parsing, where it starts, whether it uses TCP or UDP, any protocol ports. On the back end and in the intermediate language, we support using DPD signatures. It is not currently supported on the front end, again, just for simplicity of use mainly. And then also user types. So Spicy supports conversion from bytes or other formats into a more human readable format. Particularly, user types came up when we had one protocol that uses Latin 1 strings. And because it uses Latin 1 strings, it wasn't directly supported by Spicy. And that's, I mean, logical. Not very many people use Latin 1 strings, but we wanted to be able to parse it into an appropriate string. So we defined it as a user type. We'll kind of go through this process of editing the parser configuration here. The example we were walking through is called the Malcon demo. It's also known as My Simple Protocol. This is the example we walk through in the Parsnip documentation on the repository as well. We have a sample PCAP for that generated with Scapy that you can use to test and make sure everything worked out and is right. In this case, we defined port number as 8888, and we don't have any user types. The entry point isn't defined yet. You need to define the entry point as an object before you can point to it. So we'll do that. We'll come back to that at the end. As you saw in kind of the picture, fields are the building blocks of everything. And then enums are kind of the smallest unit. They can't build on anything else. So we typically start with building out the enums, then we'll build out the bit fields that may or may not rely on the enums, then we'll build out the objects. So we're working smallest or least likely to have something pointing to it, or most likely to have something pointing to it, least likely to point to something, out to the things that point to the most values. So we'll go ahead and add this enumeration, and you'll notice in the fields, you'll see field name. In enum's case, it's field value, and then as well, you have notes, and the value to appear in log is the human readable value I mentioned earlier. You can just copy the field name, or you can add more details, more information, stylistically up to you. Now that we've built that enum, the next thing to do is to build out our bit field. You'll see that this is added and that you can also delete any fields. Now we'll add the bit field. We have the bit field next because it relies on the enum. But you'll see in bit field, it's very similar to how the enum was. It has a name, it has a reference, it has a note. And the fields are very similar. They have names, they have descriptions. These have types. An enum type is assumed to be an integer. And these types, if it points to something like an enum, request a reference. In this case, it's referencing the message type enum. So it's pointing to that. And we will use names typically as our main pointer of how to understand that something points to something else in Parsnip on the back end. We will also build out a graph to make sure we don't have any self-recursive types. Spicy is unable to export self-recursive types, which makes sense. Once we build out that graph, and if we find any cycles in that graph, we'll go ahead and pull out and tell Spicy to not export the fields that are causing those cycles. Now that we've built out bit fields, we're going to go ahead and build out objects. And as we build out objects, it's important to note that each object can be used in multiple places. Objects are specifically designed to be repeated. We will not do choices in this demo. The simple protocol does not have choices or switches. You'll notice again in objects the same thing. You have object reference, object name. You have object name, object reference, object notes, and scope. Scope is also beyond this presentation, but you'll notice that it's very similar and very consistent. Dependencies are anything that is passed into the unit in Spicy. In this case, it has a dependency of length, and that'll come from the header, as we'll see later. There's only one dependency in this case, so we don't need to add dependency, and we create the object. Once the object is created, we can build out the fields. Object fields are in a separate tab because it's easier to see. And one thing that's important to note currently, Parsnip does not support reordering fields. So it is important to input fields in the order you expect to see them, as you would in Spicy. You tell Spicy to parse in the order you expect to see. It's the same principle here. Eventually, we would love to support reordering fields as well. And then we added the header object. The header object doesn't have any dependencies. And this is kind of our intro, not quite our entry point object, but the first part of our entry point object. I'll show you how we build our entry point later. But you'll notice that the fields can reference other objects, bit fields, or enums as well. They don't have to be a standard Spicy type of uint, bytes, etc. And finally, we're adding our top level. This is really our entry point object. This is what says, okay, every packet is going to contain a header and a body. And you'll watch as we're adding them. Again, field name, reference, note is very, very consistent, and that's very intentional to avoid additional confusion. These two fields reference the objects, and you'll see that it automatically fills in that a body does require an input and asks you what the input is. Now we're back to our parser configuration. Once we go back to our parser configuration, we'll go ahead and set the entry point to the message and export. It'll export in a parsnip.zip file, and we'll move into the terminal to run the backend. This demo, we won't really look at what the intermediate language files look like. If you were curious, they are on the GitHub at github.com/cisa.gov/parsnip. They're in the sample IL files, I believe. We'll unzip. It gives you a random string identifier so that you can use different versions and unzip different versions. Then in order to run the backend, you paste the input directory and then where you want it to go. So in this case, we're just going to put it to output, and that will be that will output our Spicy parser. As I mentioned earlier, it doesn't create your GitHub, your Git repository for you. You'll want to get init and git commit everything you need to add before trying to ZKG install it. This is also a known limitation that I'm fixing right now that is documented. We don't want to mess with file permissions in Parsnip. And for whatever reason, the testing scripts are not executable, so your install will fail. That's, again, noted in the documentation and will be fixed in future releases. Now I'm just going to open up to show you guys. I'm going to open up and mount this directory to a container. And I'm using a container from Seth Grover. It's just the latest Zeek container. It was just the reference I had at the time. And then once we've defined it as a safe directory inside that Docker container, we can go ahead and install. It'll run the unit tests. They should pass if you, especially if you added the execute. And there's only the availability unit test right now. And then we'll go ahead and we'll test it against a PCAP as well. And you'll see that it outputs Malcon demo general log .log. And you'll see in there that it's outputting the bits, the header version, the message type, the header length, and the body data. The body data is output just as a regular vector because it's a standard type, and then bits and message type and length is also output. So overall, that's kind of Parsnip. And the future of Parsnip Parsnip has several upcoming initiatives and upcoming goals based on community interests. One of the big things we would love for Parsnip is to get more community feedback, not just necessarily from the people that we're targeting to use it, the analyzers or analysts or other people that aren't necessarily programmers, but also from the spicy community in general. What features might make more sense to expose, how we can better serve and provide this interface to customers and people that need it that can't develop spicy for one reason or another. And additional upcoming initiatives, we already did output include some logging verbosity options, but we want to further refine that and add logging options for fields that may or may not need to be logged. For example, length fields a user may not want in the actual textual log and may just rather have just the output or just the list instead. We'd love for Parsnip to create summary logs. Exactly what this will look like, we haven't fleshed out yet, but we would love for Parsnip users to be able to flag something as an action result, perhaps, and then summarize how many actions were taken or how many results were taken based on a field or an enum. And we'll flesh that out, but to give an additional good log that isn't as verbose as our other logs. And then as I mentioned, we want to specify whether a field should be logged or not necessarily logged. Potential initiatives based on community interests. We work very closely with the Malcolm team and Seth Grover. And one of the potential interests is integration into Malcolm. This could look different in different ways, perhaps a Docker container that you can enable on Malcolm. And then ultimately, we would love to have a way to export your data either from Archime or other captures into Parsnip, so you can look side by side with your bytes field and what you're telling Parsnip to parse it as, and do that side-by-side comparison. Another potential initiative is Wireshark parsing and other similar parsing mechanisms. So the other part of Parsnip and Parsnip's intermediate language is it's designed to be generic enough that we could write another backend to create a parser in a different language. For example, Wireshark parsers. A lot of our protocols do have existing Wireshark parsers, and a lot of them don't. So refining and outputting a Lua parser based on the same intermediate language that we're creating for our spicy parser could greatly benefit the community. And then, as I talked about, an improved user interface and user experience, particularly with the bytes to what you're telling it to parse comparison. But ultimately, right now, the big thing that Parsnip needs is community engagement and community feedback. We are comfortable using parsers. Myself and my team are comfortable using Parsnip because, well, we built it. So we know it makes perfect sense to us because we built it in a way that makes sense. But does it make sense to the community? Is our documentation sufficient? Are there better ways or easier ways to communicate certain principles or certain thoughts? Is all feedback we could really use to help kind of grow and improve this, especially before we give it to the people that may not have the development or the spicy expertise to want to debug the actual output spicy code, and would rather stay up at that high level I talked about in the first place. So last but not least, overall, accessing Parsnip. I mentioned earlier, but Parsnip is found at github.com/cysagov/parsnip. And feedback or bugs can be submitted either on the GitHub issues page or in the discussion board. And that is Parsnip. Great question. An anonymous attendee asked if there are open source parsers that were generated by Parsnip. Yes. We have one open source parser that was generated by Parsnip. It is our hard IP parser. That can be found at CISA cysagov/ICSMPP/hardip. And that actually, when we release a parser that was built with Parsnip, we will include the associated intermediate language files in there as well. So if you want to go examine or investigate those, that's helpful. What other questions do you have?
And yes, just a note, you can raise your hand and we can unmute you, which I'm going to do with Benjamin.
Yes, thank you. Great presentation. So have you so I'm kind of wondering how this guy in Kansas is doing with this tool. And what's your experience? Is he kind of happy with this, or do they call you and you look at JSON? That's what I'm wondering, basically. Is that abstraction? Is it working well?
It has been working well. I use it a lot for my team. I have a couple of kind of newbies actually on my team that aren't super intense developers, and I've been having them typically develop in Parsnip, and they've been doing really well with it. It helps them kind of learn the structure of spicy and how it works without necessarily having to dive in if they're not comfortable in programming. The dude in Kansas is hypothetical, but
I mean, I'm asking because spicy is you write it in a programmer's text editor, but if you want, it's just structure, right? So you don't have to program, you don't have to write loops and stuff. You still have to kind of know what you're doing, right? So this is what this tool provides, right? It gives different abstractions that are more useful. But I'm wondering, like, in terms of like, I mean, there's like some chance for spicy to be nicer. That's one part of it, and the other part is how to find like a good place to formulate that, like outside of some DSL. Basically, this is what you're trying, right? You build like a visual DSL in some sense.
Yeah, and that's kind of the ultimate goal of Parsnip. It's building to being a visual data language. The idea is to have it kind of, I don't know how familiar people are with Splunk, but in Splunk, you can kind of just feed it random data and then more or less highlight what different pieces of the data you want to extract and say extracted as this or extracted as this. And that's ultimately the hope with Parsnip, is that we can just kind of give the user the bytes and they can just say, I want this byte to be interpreted as this. And then Parsnip handles the actual writing, what it is. So highlight, even if they highlight a byte and they're like, this should be a number. Parsnip, they don't even have to know the terminology uint or number of bytes or number of bits. We figure that all out for them, and then they just basically point and shoot is the ultimate goal, to be more of a visual language than a textual based language.
And that sounds surprising to me, right? So like, I mean, I would be scared looking at like some byte salad basically, right? And like clicking on stuff. But yeah, that's coming, right? With your Wireshark interface kind of thingy.
Yeah, that's the hope. And yes, for us as programmers, especially, we look at bytes and we look at the text language and we're like, this is good. And it makes sense. Particularly spicy makes a lot of sense. But for our analysts, they're more used to looking at data in kind of that textual format, and they're more used to seeing just kind of a string of data that they have to then tell something how to extract data out of. So it's more to appeal to them that are in more of kind of their world, meet them in their world, rather than trying to get them to come and learn spicy with us. I've tried. A couple of them are like, nope, I don't program. Like, it's not really programming, but
isn't that just, you can't hire these because you're in government, right? I mean, that sounds like a fireable offense if people refuse to do their work.
That can be it too. Yeah. Again, also hiring people that know spicy. And as I said, I do use it as a framework for my developers as well, my new developers, to kind of get used to just what spicy looks like. They'll kind of start out building a Parsnip intermediate language and something they're kind of more familiar with, or basically they're just translating tables into JSON. And at that point, then they can run it through Parsnip and see, okay, this is how spicy looks in comparison to this structure I kind of already know or am more familiar with. So we also use it as a teaching tool.
Are there any other questions? I'm just going to give it a couple more seconds to give everyone a chance to. Yes, there is one more question in the Q&A. Wonder if you've looked at KaiTai/KSY files as an intermediate language.
We have not. That's definitely something that I will go look into. After this, yeah, I did not know that this existed. So this will be a great thing to look into. And see if we can leverage. It looks, just off of my first glance, looks very similar to what I'm describing as the ultimate goal for what Parsnip looks like.
Okay, thank you. And I'm going to give everyone a couple more seconds to think if they have a question. And while you do that, I want to highlight that our next webinar after this is going to be on the 11th of December at the same time. And the topic is Zeek file extraction and automating malware analysis by Seth Grover, who has been mentioned in this talk today a couple of times, finally. And it looks like there are no more questions. So thank you very, very much for giving your talk today. I enjoyed it a lot. And I hope that I'll see everyone here again on the 11th of December. Nice. Thank you, everyone, and have a